Alright, so this video is on projectiles. This series is going to be on projectiles, falling objects, that kind of thing. Just going to go through some notations quickly first. So we're using S for distance, U for initial velocity, V for final velocity, A for acceleration, G for acceleration due to gravity, which we're going to say is equal to 9.8 meters per second. And if we ever have to split into coordinate axes, we use y and x like normal. And also here's some suvats just to remind you of some equations you'll be using throughout all the videos. And we're going to, in this first video, go on for a question which we have. So our problem for this video is we have a ball which has been kicked off a cliff with a velocity only in the horizontal direction of 20 meters per second. It has no vertical component of velocity. It hits the ground 3 seconds later. How far away does it land and how high is the cliff? So this is what we know. We know our initial velocity in the x, we know our initial velocity in y, we know the acceleration, the time, and we don't know the height or the distance. So we'll quickly sketch our problem, and we'll say that this is some cliff here that we have. This is our ground, and we'll say this is our ball, and it has some trajectory which goes a little something like that and hits somewhere down there. We're going to call this H, we're going to call this S, and now we're just going to solve for H and S. So we'll start with S, and we know that any velocity in our x direction and any velocity in our y direction have no effect on each other. So the whole shoot a gun, drop a ball, and the bullet and the ball will land at the same time with no friction or curvature of the earth. So that means we can use our relationship here. So S equals, and then we use our x initial velocity, which is 20, by our time, which is 3, plus half. Now we have no acceleration in the x, so it's by 0, by t squared is 9, but all of this can go, and we're just left with S equals 60. Very easy. And now for H, we can use exactly the same relationship, and we know now our initial velocity in the y is 0, so that by our 3, so this can go, plus half. Now we do have an acceleration, which is 9.8 meters per second. And we also have our time squared, which makes 9. And again, we just punch that in, and we got 44.1. So these are both meters, because we use SI units for everything. I know it's a very simple problem. It's a very quick one, and we'll be getting onto much harder problems as the videos go on, but we just thought we'd start off with something nice and easy. So don't forget, if you want to see the next video on projectiles, just click here, and if you want to see more from my channel, just click down here.